Hey everyone, it's Jared here from the Abstract team. And in this video, I'm going to show you exactly how to create your own Paymaster smart contracts and deploy them to the Abstract testnet. I'll first quickly walk through how native account abstraction on Abstract is built into the protocol, so the protocol knows about what paymasters are and they're natively supported inside of transactions. Then we'll dive into Solidity, build out a smart contract and ship it onto the testnet and see what it looks like on the Block Explorer. As always, there will be a link in the description to any resources as well as the source code, so you can jump right into the code if you prefer, as well as a link to the Discord server to grab some support if you get stuck at any point throughout the video. With that said, let's dive right into the tutorial. So if you've reached this video and you're wondering what is a Paymaster, we'll first give a quick one-sentence summary of what it even is, and then we'll dive into how it works under the hood. So essentially, a Paymaster is a smart contract that can pay the gas fee for a transaction on behalf of somebody else. So if I submit a transaction and I opt in to use a Paymaster, I won't pay for the gas fee. Instead, the Paymaster contract will cover the gas fee for me. The most common workflow for this is to use Paymaster contracts to cover the gas fees of your users of your application. This is especially relevant when you're onboarding new users who have no idea what gas fees are or what wallets even are, and essentially you don't want them to provide funds to their wallet and pay gas fees and learn all of these new concepts. You can abstract all of that away by paying the gas fees for those users so they can more easily onboard and continue using your application. Before we dive right into the Solidity side of this video, I thought I'd give you a quick little overview of the concepts and an understanding of how Paymasters are actually built into the protocol and natively understood when it comes to building on Abstract. So the flow that this occurs through at a high level is transactions get sent via an RPC and they hit a special system contract called the bootloader. Now, there are a couple of nuances to this. We won't go into too much depth into this video, but essentially there are a set of system contracts that are deployed at the chain's genesis. So there's a set of special contracts that as soon as the chain is created, these system contracts or the special contracts are deployed. And one of those contracts is called the bootloader. The bootloader actually receives all transactions sent to the chain. And basically what it does is it has an understanding of what paymasters are. It knows how paymasters should look, and it knows what functions each paymaster should implement. So basically it makes the decision to say, is there a paymaster on this transaction? So it receives all the transactions. For each one, it says, is there a paymaster set? If there is, it'll go down this green path on the right-hand side here, and it'll first send it to the paymaster to say, hey, this transaction is claiming that you're going to pay the transaction fee. I'll let you go ahead and decide, are you actually going to do that? And then once that goes through, if it's successful, it'll continue on and actually get sent to the account. However, if there's no paymaster set on the transaction, then it will skip this step altogether and basically just continue on to the account. And the account will be responsible for paying the gas fee rather than the paymaster. Now, when it comes to flows when working with paymasters, there are two common flows that we're going to touch on in this video. The first one is what we're actually going to build, and it's called the general paymaster flow. Now, this basically just refers to what we've been talking about already, where you cover the gas fees for your users' transactions. The alternative to this is what's called a approval-based flow. So we'll say it to approval-based flow. And what this refers to is not just when you want to cover the gas fees for your users, but you want your users to actually pay in a different token other than ETH. So ETH is the native gas token on Abstract. What if you want your users to pay in another ERC20 token? And you can kind of, inside of your smart contract, make the swaps from that token to pay the bootloader in ETH and perform that approval-based flow, because you will require the users to actually approve spending that token on that ERC20 token before you actually perform this Paymaster process. So what we're going to build in this video is just the general flow. We'll keep it super simple so you get the bare bones implementation, and you can kind of take this smart contract that we build throughout this video and then go and create whatever you want in your own custom Paymaster. Before we get started, I want to show you a couple of dependencies that you'll need to have installed, how to check if you have them on your machine, and there will be links in the description below for you to go and find them if you don't already have them. The first thing you'll need installed is Node.js on your computer. You'll need at least version 18 to follow along with this tutorial. Second thing you'll need is Docker. You'll need Docker installed and actually running on your machine. We're going to be using this for our local node just to deploy smart contracts and test them out on a node running on our machine. And if you're in a Windows environment, I like to use Ubuntu with WSL, and I'll quickly show you how to check if you have that and how to install it if you don't already as well in this tutorial. The CLI that we're going to use is not recommended to be used on a Windows terminal, so I would strongly recommend if you're on a Windows machine, install WSL, and I'll show you how to do that quickly before we dive into it as well. Okay, so if you're on Windows, you want to check if you have WSL, and if you don't, it's actually the same command. You can just do --install. And for me, I already have the Ubuntu installed on my machine, so it's just going to swap into this Linux environment where we can run Linux commands, and it's going to act as if it were a Linux environment for the CLI that we're going to use as well. Then for Node.js, you can just do node-v. You can see I've got v20.10 installed. And for Docker, you can do docker-version to check if it's installed. And you want to make sure that it's actually running. So you can do docker info, and that will print out if it's actually running on your machine. So if you've got all of these commands set up, you're ready to actually start the tutorial and create our first project. The next thing we're going to do is run this zksync CLI create command. And first thing this is going to ask is what the name of the project that we want to create is. Basically creates a new folder for us to initialize our project in. So let's just say Paymasters abstract demo. And for the type of project, let's select contracts. We'll just use the latest version of Ethers v6. And I'm going to use Solidity in this tutorial. So we'll select hard hat and Solidity. Next, it's going to ask you for the private key of the wallet responsible for deploying the contracts. I'm just going to leave this blank for now because the setup actually comes pre-configured with some private key, public key pairs that we can use to deploy smart contracts or interact with smart contracts on the local node. Basically, when you spin up the local node, this list of wallets will have funds available for you to spend on your local node that we're running inside of a Docker container. So I'll just leave this blank for now, and I'll go ahead and use npm. You can choose whatever package manager that you prefer. Once that's done, you'll see it prints out this change directory command. So let's just paste that in to change into the newly created project, and we'll open this up inside Visual Studio Code. Awesome, so I'll give you a quick little walkthrough if you're not familiar with this already. Let's go ahead and open up the contracts directory in here. You can see we have a couple different smart contracts, and it actually comes out of the box with two different paymasters that we're gonna take a look at, but we are gonna build our own paymaster from scratch just so that we can really deeply understand what each line of code is doing inside of our very own paymaster. And you can go ahead and customize any aspect from there. So we'll leave the paymasters in for now, but we'll go ahead and delete the ERC20 and the NFT folder since we won't be needing those. We can also safely go ahead and delete the greeter.sol. We can also go ahead and deploy the tests since we won't be writing tests for this video. Obviously, I would encourage you to write tests for your smart contracts, but just for simplicity, in this video, we're not going to. And again, underneath the deploy directory, we can safely go ahead and delete the ERC20 and the NFT directories from that deploy directory there. If you take a look at the package.json scripts section, we can safely go ahead and delete the tests since we're not going to be using those in this video. But there's a couple of commands that we're going to be using. We'll be using the clean just to clean up our environment and make sure we're able to compile our smart contracts from a fresh state. We'll compile our contracts into bytecode. We'll deploy those smart contracts, well, just really one smart contract, which is our Paymaster contract, onto first a local node running inside Docker, and then later on we'll deploy to the Abstract testnet as well. Once it's deployed, we will be able to interact with that smart contract, in which we'll write a little script in this TypeScript interact.ts file to actually submit a transaction that utilizes our Paymaster to sponsor the gas fees of our transaction. So really, we have deploy, which is this file here, which deploys a smart contract. We have the interact script, which is this interact file here. And within this utils file, we have a couple of helpful functions that we're going to use. Some of these, like get the provider for the RPC, we have a wallet that reads from our environment variables file here, which we haven't populated yet, but we will grab one of these rich wallets that come out of the box all the way down the bottom here. So here you can see there's an array called local rich wallets that will allow us to easily kind of submit transactions to our local node, since each of these has a lot of ETH on that local node configured out of the box. So we won't need to worry about getting any testnet funds until later when we go to deploy this onto the Abstract testnet. Out of the box, you can see it also comes with two Paymaster smart contracts, one for the approval workflow and one for the general workflow. We're going to build a general Paymaster workflow in this tutorial just to keep it simple, but likely I'll make a future tutorial for this approval flow as well. But this video, we're going to use some of the logic in this general Paymaster. So feel free to have a look around at the functions and interfaces and stuff that's going on generally in this smart contract if you choose to. But we're going to create a new file called mypaymaster.sol at the root of the contracts directory. And here is where we'll actually create our very own Paymaster smart contract. The way that you build Paymaster smart contracts on Abstract is by implementing an interface called iPaymaster. So what we're going to do is we're going to import that interface and we'll copy across any of the necessary functions that we need to implement. And then we'll go ahead and actually implement the logic for each of those functions. So first, of course, we're going to start off with the license and the version. And then we can safely say contract myPaymaster is iPaymaster. And then what we need to do is just import the actual iPaymaster smart contract. And you can find these, if you're curious, inside of your node modules under the @matter labs, ZK sync contracts, L2, system contracts, interfaces, iPaymaster. Different video is the iAccount. So iPaymaster is the one we're doing for this video. And here is the interface. So you can see interface iPaymaster defines two functions, validate and pay for Paymaster transaction and post transaction. So hopefully these names are somewhat self-explanatory, but the validate and pay is going to determine, am I going to sponsor this transaction based on whatever rules I write within this function. And post-transaction is what occurs after the execution of the transaction is complete, except for, as you can see in the comments, in some cases, if the transaction results in out of gas, sometimes it won't reach this point. One easy way that you can import this without looking at any documentation or source code is if you actually just copy the relative path of the iPaymaster file here, and then go import iPaymaster from that directory and just remove the node modules /. You can actually easily import it this way. So now, even though it's underlined in red, if you control click into that and you're successfully taken to this interface, that means you have successfully imported this smart contract and specifically this iPaymaster interface from this file here. If I just give my VS Code a quick refresh, you can see now the red underline is gone and it's saying it should be marked as abstract. And if you've ever inherited smart contracts before, you should know that it basically means, well, you're saying that you inherit this interface, but you don't really, you're not doing it properly, right? And the reason is we haven't implemented the necessary functions that define this interface here. So let's go ahead and actually copy across everything from this interface into our myPaymaster smart contract. So let's just, for simplicity, delete all of the comments here. And now, instead of leaving the semicolon, we can just open brackets and say to do implement this function. And we'll do the same thing for post transaction here. To do implement this function. Now you can see it looks like we're missing one little import here from a transaction. So if we go into iPaymaster, I'll just show you how you can kind of figure out, well, where do I import these things from? Transaction, if we control click into that, you can see this is coming from a file called transaction helper. So in our smart contract, again, we can do the same process, go into where we're importing these smart contracts from. And it was transaction helper, which is under libraries. And here is transaction helper. So we can, again, go ahead and copy the relative path here. Just for simplicity, for this video, I'll save you some time and import any of the necessary smart contracts and interfaces and libraries, whatever we need for this video. But just to show you, if you want to customize it, here's how you can kind of go about finding where the smart contracts are, what's within them, and how to actually import them into your contracts as well. So just to save you some time, for this video, we'll be using transaction from transaction helper, which is the one I just showed you now. And of course, again, the source code will be linked in the description. I'll just zoom out for this portion. The other thing we'll need is the iPaymaster flow from the iPaymaster flow interface. We'll also need the formal address or the contract address of the bootloader. In the iPaymaster interface as well, we're going to import both the iPaymaster, the execution result, as well as the Paymaster validation success magic variable here. I'll just zoom out for you if you are going to write it out manually, but again, the source code for this file will be in the description if you want to follow along with that, whatever you prefer to do. Okay, so now we've got all of the imports. Just for simplicity, I think it's easier for us to go ahead and import anything we're going to need in the video just up front so we don't go back and forth. Now let's talk about what these functions actually do. So step one, we have this validate and pay for Paymaster transaction. So what does this actually do? As the name suggests, validate and pay for Paymaster transaction basically means validate, well, do I want this Paymaster smart contract to pay the gas fee for the transaction that it's kind of receiving as an argument to this function. So a transaction will come in and it's up to us within this function to say, do I want to validate this and say, yes, I want to go ahead and pay the gas fee for that transaction. And then the second step of this function is pay. So if we validate and say, yes, I want to pay, well, we actually go ahead and do the payment part as well. And the thing or the address that we're going to be paying is to the bootloader. So essentially this is a two-step process. One, do we want to go ahead and pay for the transaction in this function? If yes, continue to step two, actually pay the bootloader the gas fee for the transaction. And what you'll notice is this returns two variables here. We have a magic variable and we have a context variable. The one we really care about is this magic variable. Basically, if we return a magic or kind of set this return value of magic to this thing we imported called Paymaster validation success magic on line number 5 here. You can see this came from the transaction helper. Basically, this is the value that this function is looking for if you agree to continue and pay for the transaction. So as long as you return this value, for example, if we just put magic equals this and close that function out, we're actually going to pretty much just say yes to every single transaction and continue regardless of what the transaction is. So this is almost the most basic implementation of this function, is just to say, yeah, you know what, I'm just going to accept any transaction and pay the gas fee for it. Now, the one caveat to that is this is always going to fail because we're not actually paying the gas fee. So we've done the first part of validate, and our validation here is always saying yes. So it's a very simple form of validation. But the second part of this function is to actually go ahead and pay the gas fee. So up to step 2 of our little comment here, once we've reached step 2, we actually need to send the funds for the bootloader. So all we need to do now is calculate how much gas is required for this transaction to go through and go ahead and send that amount to the bootloader. The other thing I skipped past was this context. If we skip into the iPaymaster interface and we take a look at what this context is, you can see an array of bytes, which will be passed to the other function in this interface called post transaction. So we're actually not going to implement post transaction just because I'm going to keep it as simple as possible. But if you want to pass any information, you can see the return value context is the second variable that we return, and the first argument to post transaction, the other function within this contract, is also the context. So it's basically saying if you want to pass any information between, well, this first step and the step that occurs after the execution of the transaction, you can provide that in this context variable here. So let's actually comment, let's maybe just copy paste these comments into this function here, just to say, okay, one, do we actually want to run this function? And obviously, you'd probably want to do some checks here, like does the transaction have a certain data? Is it coming from a certain smart contract? Is it going to a certain smart contract? You'd obviously want to have some rules to restrict who can use the Paymaster. Just for simplicity in this video, we're just going to leave the validation pretty much empty. We're just going to go ahead and allow anybody to use our Paymaster. And then step number 2, let's copy and paste this down. So now we're going to actually go ahead and pay the bootloader the gas fee for the transaction. So the first step of that is to actually calculate the fee that we're going to send. In order to do that, we can calculate that value by saying uint256 required ETH is equal to the transaction gas limit times the transaction max fee per gas. So hopefully this is kind of self-explanatory. We're calculating the kind of maximum amount of gas that the transaction is willing to spend by seeing, okay, how much gas is the maximum that this transaction is willing to spend, and multiplying that amount of gas by the fee, which is measured in wei per gas. So for example, if we said, well, the gas limit is 10, and for each unit of gas, I'm willing to pay 5 wei, then we have a required ETH of 50 wei. So we're gonna send 50 wei to the bootloader in order to pay the fee for this transaction. Now, you might be wondering, if I'm always paying the maximum gas limit for my transaction, aren't I getting robbed? Like, obviously the transaction is not always going to consume that maximum top end of the gas limit times max fee per gas. So why am I sending that amount to the bootloader? And I'm glad you asked. So here's where we're going to introduce the concept of refunds. So gas works a little bit differently from Abstract to Ethereum in that if you build a paymaster that essentially overpays the bootloader for a transaction that it handles, for example, if we simplify it down to dollar values, if your paymaster pays $1 to the bootloader and the transaction gas fee is only 20 cents to run that transaction, you've overpaid 80 cents for that transaction. And what the bootloader is going to do is it's going to see that you've overpaid and actually refund you the difference. So in the background here, I have pulled up an example transaction where you can see this in action. So for example, this is a mint of an NFT of quantity of 1. So it's minting 1 NFT to this address. But what we're interested in is this fee section here. So you can see 25 cents was paid by the paymaster. So the gas fee was 0.00013 ETH, which equates to $0.25 or 25 cents. And you can see initially the paymaster paid $1.70 for this transaction. So it's paid a lot more than what it actually cost, which was 25 cents. But this is because the gas limit was a lot higher than the amount of gas used. So you can see $1.70 was sent and refunded was $1.45. So if you do the maths, 25 cents plus $1.45, I do the math in my head, that is $1.70. So you can see basically the refunded plus the actual fee is equal to the initial. So basically, initially sent $1.70 and the actual fee turned out to be 25 cents. So we've overpaid by quite a lot and we are therefore refunded the remainder of that gas fee. Okay, so all that's left to do now is actually send this amount of ETH as a transaction or a transfer to the bootloader. And Copilot has actually figured that out for us. So let's pay the bootloader the gas fee for the transaction. Basically, we're going to say payable and wrap the import that we had called bootloader formal address. And we are going to say call open curly brackets. And as you can imagine, the value in here is going to be the required ETH that we just calculated. So we're basically transferring this amount of ETH to the bootloader, which is imported the smart contract address for the bootloader in this variable here. And we don't need to send anything extra along with that value. What we can then do is actually grab the success value out of this to see if this actually succeeded, obviously. And then what we can do is require that the transaction was successful. So basically say, yep, that was successful or failed to pay the bootloader for the transaction. And that is actually all we need to do. We can clean this up since we don't use these variable names. We can just get rid of them. And I think we'll just leave that in just to make it obvious that you can choose to, if you want, say, I don't know, context is equal to empty string. You can put that down the bottom if you want and just pass that on as the context to the post transaction. We're not going to implement that in this video, so we'll just leave that blank and leave this little yellow squiggly line for us. Awesome. So hopefully that now makes sense. Essentially, step one, validate. Maybe you would want to put some kind of conditions in here to say, is the transaction going to my NFT collection, or you only want to sponsor the gas fees for a specific smart contract, or that meet a specific criteria, or they're less than a certain amount of required ETH. Any custom rules that you want to put in here, you basically say, if I want to continue, return this magic value. Otherwise, for example, if this fails, then we won't return that value and we'll error out. But some point we need to validate, and then step two is actually pay the gas fee for the transaction to the bootloader. So hopefully that makes sense. What we can also do is go ahead and take a look again at the general paymaster that comes out of the box. What we'll notice here is it does a couple of things that we're going to talk about later in the video. But first I wanted to show you that this only bootloader modifier exists on both of these functions. If we just collapse this down, the only bootloader modifier is defined up here. And as the name suggests, we only want the bootloader to call these functions. So we're gonna go ahead and add that into our contract as well. And down the bottom beneath the two functions, you'll also notice a withdraw function with the only owner modifier attached to this function as well. And basically this is so that if you're deploying the Paymaster smart contract, and you'll need to provide some funds so that it can pay for the gas fees for the transactions. Let's say at some point you want to say, you know what, I want to get my funds out. We're going to be able to withdraw the funds from the smart contract and get them back into our wallet. And using the only owner modifier, we'll be able to restrict access to just our wallet. So not anyone can just take our funds from the Paymaster. And on line 78 here, a little sneaky one, but a very important one as well, is if we want to be able to send funds to this smart contract, it needs to have this receive function here to actually be able to receive the money that we're going to send it. So we're going to go ahead and implement these, as well as both the only bootloader modifier up here, and we'll also go ahead and set up this full smart contract so that we have access to the only owner modifier as well. So firstly, we'll go ahead and copy this across from the general paymaster into our paymaster here. So just at the top, just to make it as simple as possible, go ahead and paste this in as our only bootloader modifier. And then on our first function here, after the payable, we'll say only the bootloader can call this one, and we'll may as well go ahead and do the same. We're not actually going to be implementing this one in this video. You can choose to do that if you want to, but for this video, we'll just chuck on the modifier and leave it empty. Next thing we're going to do is actually go ahead and copy across the withdraw function and the receive function so that we can send and receive, send and withdraw ETH to the smart contract. And we'll just go ahead and copy paste those down the bottom here as well. So now you can see we're just missing the only owner modifier. I guess we could probably write this ourselves, but just to show you how you can also import smart contracts from OpenZeppelin, which is a common pattern that you're going to likely do. We can go ahead and copy this OpenZeppelin smart contract import from the example general paymaster, paste that on line number 8 here. And let's also say our smart contract is also I-ownable. Oh, sorry, not I-own. And we should be good to go. So now we have access to the only owner. It's no longer sad with a red squiggly line. And I think we are good to go. So if we jump back into our terminal now, we'll quickly hit a clean. So npm run clean, npm run compile. And back in the VS Code, just if you're curious, you'll see we generate this cache ZK file. If this successfully compiles, it's still compiling in the background. There we go. So we have the cache and the artifacts ZK, where you can find all of the ABIs, and down the bottom, the big long bytecode for your smart contracts, if you're curious. Then what we're going to do is inside of our hard hat config, you'll see that our default network is set to zkSync Sepolia testnet. What we want to do is set it to in-memory node, which is a local node that we're going to run using our Docker setup that hopefully you already have installed or you installed earlier on in this video. We're not going to be using zkSync in this video or Dockerized nodes. We will go ahead and add the abstract testnet here in, let's go ahead and do it now as well. So for abstract testnet, let's go ahead and add the URL, which is this value here, which you can find on the documentation. The ETH network, since it is an L2, the testnet is built on top of Sepolia. we'll set the ZK sync flag to be true. And then if we want our contract verified so we can view it on the Block Explorer, let's go ahead and add this verify URL here. I'll move my head out of the way so you can see that one, but that is all available on our documentation as well. We'll leave the default network for now to be in-memory node. And now I'll show you quickly how you can spin up a local node just in one command. It's not too much stress. And then we'll move on to actually deploying it to Abstract as well. So jumping back into the terminal, you can run this command zksync CLI config. Nope, it doesn't like that one. Config. Yeah, zksync CLI dev config. So this one here, if I just clear things out, zksync CLI dev config, and basically select in-memory node, and you don't need to select any of those additional options as well. Then what we have is zksync-cli dev start, and this, as you can see, it will pull in the container. I've already got it running in the background, as you should be able to see if I open up my Docker here. There we go, there he is, and it is running in the background. So this is chain ID 260, and that is now a local in-memory node that we can use with the rich accounts inside of the deploy utils file here. So this is an array of accounts that are already set up with some funds on the local node. So now what I'm going to do is actually just grab one of these private keys. Let's grab the first one and paste it into this environment variables file here, which basically says here is the wallet that I want to deploy my smart contracts from. So now we have cleaned and compiled. Next step is npm run deploy, which is going to run our deploy script. And as you can see, it's still configured to use the greeter smart contract. So let's go ahead and update this. So instead of deploying the greeter, which was the default contract that comes with the template, what we're going to deploy is my Paymaster. And this has no constructor arguments. So actually, to make this even simpler, we can just replace this with one line, await deploy contract my Paymaster. And this is basically just grabbing the name of your smart contract and running it through this deploy contract function, which is in the utils file here. So now if we jump back into our terminal, run npm run deploy once again, you'll see we're not trying to deploy the greeter anymore. We're instead trying to deploy a contract that actually exists, which is our Paymaster here. So here is the smart contract address that we deployed it at. And what we can do now is copy this smart contract address, and then back in our VS Code, if we open up interact.ts now, we're going to go ahead and paste that smart contract address on line number 6 here. So now I guess the final step is to actually send a transaction that uses our Paymaster to pay for the gas fees. So what we're going to do is inside of this interact file, let's go ahead and just kind of delete everything that's in here except for this first line running script to interact, because that is helpful just in the logs. So when you think about it, what we really want to do in this function is basically just submit any transaction from any wallet to any wallet doing anything. And we just want to chuck our Paymaster contract address as the Paymaster. So it's actually very simple what we're going to do inside of this function. We're just going to submit a transfer of ETH from one wallet to the other, or maybe we'll just send one empty transfer. We'll just send them a message from one wallet to the other. And basically, we're going to chuck in our contract address as the Paymaster field of that transaction. So from our utils file, we have this get wallet function. So let's go ahead and first actually get our wallet. So we say wallet is equal to get wallet. Then what we're going to do is from that wallet, we're going to create a transaction. So we say const transaction, or just ts is equal to wallets.send transaction. And you can see this accepts a transaction request. And we can take a look at the required fields here. We're going to just send 2. So we're going to send one of these other rich accounts. So we'll import rich accounts of the rich wallets on line number 2 here. We'll grab a random one out of there. Let's just say we'll send it to index number 3 of that array, dot address. So that just grabs this value here, 0, 1, 2, 3. So OXA1 is who we're going to send the transaction to. And we could send some ETH, but just to show you that it's not necessary to have any funds, what we can do instead is just send them an empty kind of value and provide some data instead. So for our message, let's just send them number 69 again, like we did in the previous video. And that looks good. So we're actually going to await that transaction. So now we have the transaction response. We can also wait for the transaction to get mined. So we'll say const response is equal to await t.wait. So that will just wait for it to be mined, as you can see here. Now, all we need to do is say, well, in this transaction, let's actually use a paymaster. So there is a field for that underneath custom data. So open up the custom data object, and within here, you can see we can provide the custom signature like we did in the custom smart contract native account abstraction accounts video, if you've watched that. But in this video, we're going to use paymaster params here. And paymaster params, as you can see, expects a paymaster params object. So the fields that we need here is paymaster, which is the address of the paymaster. So for us, we stored that on line number 6. So we can just say contract address, and then paymaster input, as you can see, expects bytes like. So byte stream input for the paymaster. This is not that well documented, I would say. Basically what this expects is if we jump around into the definition here, and you can see, well, it's not documented well there either. But basically, this is any additional information that you want to send to the paymaster. In this video, no, we're not going to go into it. We're just going to send an empty string. So for us here, I think paymaster input, we can actually just say OX with empty value. So basically, we're not going to provide any new bytes for the paymaster to be sent. Now, down the bottom of this function, we can say console.log response, just so we can see that in our terminal when we run this script. And that is looking good. So let's go ahead and run this script now. So we'll jump into the terminal. And what we can do is let's go ahead and run npm run interact. And it looks like we've got an error. So I'm actually blocking this error. I'll move myself up here for now. You can see the pre-paymaster preparation error. The standard paymaster input must be at least 4 bytes long. So this is where I believe earlier in the video, depending on how I edit it, is what we talked about. There are 2 separate flows. There is a general paymaster flow and the approval-based paymaster flow. So in order to kind of standardize this, there is actually a field called the paymaster input field, as you can see, and it is just 4 bytes that basically declare, okay, what flow am I going to use? So all I need to do is say what flow we're going to use, which in our case is the general paymaster flow here. And the way that we're going to do that is by, instead of saying paymaster input is OX here, let's actually just remove paymaster params for now. And we're going to create a new object called paymaster params up here instead. Params equals empty object. And there are a couple of helper functions that we can access from the ZK Sync Ethers library for us to kind of get some help in generating the values required for us to put in that paymaster params object here. So the first one is actually, we're not going to generate an empty object. We're going to use this helper function. So get paymaster params, and that is imported on line number 4 here. And what that expects is, as you can see, first of all, it expects, again, the address of the paymaster, which is what we originally provided. So we can use contract address for that. And then it expects a paymaster input of type paymaster input. So if we grab a look at what that looks like, you can see that is either a general paymaster input or an approval-based paymaster input. So for us, we're going to use general paymaster input. So here you can see we just need to set a type to general, and inner input again was that any additional information that we want to send to the paymaster. So what we need to do now is we just need to create an object here as the object with a type of general. So you can see if autocomplete shows, do I want approval based or do I want general? For us, we want general. And the only other required field for a general workflow is inner input. And for us, we can just set that as either, as Copilot is suggesting, an empty array, or I believe we can just set this as OS as well. Now, I'll just show you the other helper functions that are available. So if you wanted to do an approval-based workflow, instead of kind of writing this out, there is a get general paymaster input that you could use to generate this value that we need here. Or there is also get approval-based paymaster input that you can kind of utilize to help you out in generating this paymaster params object. But for us, we've already done it this way, so we're happy with that. Now all we need to do is provide the paymaster data, our paymaster params, sorry. So we can do paymaster params is equal to our object, or in JavaScript, you can just simplify it if the key and the value are the same. So here we're just going to provide this object that we generated into the custom data. So basically specifying, yes, our the address of the paymaster that we're going to use is the smart contract that we deployed, and we're going to use a general workflow, meaning we're not going to do any stuff like swap ERC20 tokens to pay for the gas or anything like that. We're just going to sponsor the gas fee outright for the transaction. Cool. So now we're looking good to go ahead and run the interact script again. Jump on over to our terminal, npm run interact. And now we have a new error. Okay, so this one says paymaster validation error failed to the bootloader. Okay, so this, I think we've messed up our error message in our smart contract. So at least we know where it's hitting because of that terrible error. We are hitting here, line number 40. So failed to the bootloader. We probably should have put pay in here, as that doesn't really make any sense. But nonetheless, we've figured out what the issue is. So basically what this means is the paymaster tried to pay the bootloader, right? It validated it, and it said, yep, I'm agreeing to pay the fee for this transaction. So I'm going to go ahead and send the required gas fee on line, if we swap back over here, on line 34 to 39 here, calculate the amount of ETH we want to and send that amount. However, our paymaster smart contract doesn't have any funds to send the bootloader. So it's trying to send it to the bootloader, but it doesn't have any money. And if you remember in our VS code down the very bottom, we snuck in this little receive function so that we could send some money to our paymaster in order to actually transfer it to the bootloader here. So now in our interact script, before we submit this transaction, what we need to do is actually send some money to the paymaster so that it can afford the gas fees that it's trying to send to the bootloader. One little thing I might clean up just to make it more obvious, the separation, is I will cut this and say paymaster params is equal to that. So we don't have two separate statements, and close out the bracket there. Cool. So now on above this, basically we want to, step one, send some little money to our paymaster contract so that it can pay the bootloader. And then step two, send an example transaction utilizing our paymaster to cover the gas fees. So to do that, let's say const load funds to paymaster transaction is equal to await wallet.send transaction. This time we're going to send to the contract address, which is our paymaster up here. And then the value that we're going to send is, let's say, pass ether, and we'll import that from line number 3 here. How much do we want to send? Let's go ahead and send 0.01 just as an example, and we will await that. So we'll open brackets here, close brackets here, and then we'll say .wait. And this should now, we basically want to await this whole thing. So this should be a transaction receipt. Awesome. And then once we continue with that, I don't even think we need to store that actually. We can basically say await the transaction and then await it to get mined. I know the syntax is a little janky here, but hopefully you get the point. Once we've sent some funds to our buddy, the smart contract up here, we'll just go ahead and nuke the unused dependencies while we're at it. Once we've sent the money, then we can continue with our example transaction that uses the paymaster to sponsor the gas fees. So this should be good now. We'll jump again back into our terminal, try one more time, interact, and beautiful. It looks like it worked. So here you can see it was to that rich local wallet address that we sent it to, and from our OX366, which was the account that we put into the environment variable via its private key. What we can't really see is any information about the user's balance. So what can we do to kind of print that out on the example here? We can actually just get rid of this since we only need to really do it as a one-off. You can choose to keep it if you want. I'm just going to go ahead and comment it out so we remember what it was doing, but we don't need to keep paying the paymaster every time. So we can just use the existing funds that it has. What I would like to do is console.log. I believe inside utils there is a get balance function. We'll just do wallet.getBalance and print that out. So basically, we'll print out balance before, and we'll print get balance. Sure, let's try that, Copilot. And then afterwards, let's print out the result again. So let's just comment out the transaction for now. And so we say balance before, the transaction will go through, and hopefully this prints out correctly with the formatting and stuff so that we can see what's actually going on. Run that again, balance before, and I mean, it's a big long number, but you can see the balance before and after is the same. Whereas if we commented out this Paymaster stuff here, and we just sent that transaction, we would be paying for the gas fees ourselves. And if we swap to the terminal, this balance will actually go down. So you can see it's kind of confusing, but it does go down in the second half here. So we start out with more, and then we pay the gas fee ourselves, our balance goes down. Whereas if we add the Paymaster back, run it again, our balance does not change from that because the Paymaster is actually paying for the gas fee. Now let's go ahead and deploy this to the Abstract testnet. We don't need to really change anything about the files. We just need to point our deploy scripts and the interact scripts to a Abstract testnet and the contract that we deploy on the Abstract testnet. So what we can do is jump back into VS Code here, inside hard hat config, scroll up to the top and replace in-memory node with Abstract testnet. And what I'll do next is inside of the environment variables file, we stored one of the example private keys of a local rich wallet. What I'm going to do now is I'm going to use one of my personal wallets. This wallet has no real money. It has never had any real money, and it will never have any real money. I purely use this account for testing purposes and videos like this. You should never put an account that has real money or will have real money just in plain text like this. I'm not going to go too deep into why in this video. I would recommend watching Patrick Collins' videos if you want a lesson on why you shouldn't do this. But just for simplicity in this video, I'm going to use a purely test accounts private key, paste it into my environment variables file, and continue the deployment from that account. The first thing that we'll need to do before that is actually grab some testnet funds from the Abstract faucet or bridge them across from Sepolia. And I'll quickly show you how to do that, and then we'll continue on to the deployment script. So from the Abstract documentation, I will turn my face back on over here. You'll see if you scroll down, I'm sure it probably has changed a lot by the time you watch this video if you're from the future. But if you go to the tools and integrations, you'll be able to find some faucets, and in the previous video I actually used the third web faucet. So if you go to thirdweb.com/abstract testnet, and sometimes you'll be able to grab some testnet funds from the faucet. It seems like it's empty right now, but worth a shot. If you have no funds, you can go to the bridge and bridge across some Sepolia from Sepolia ETH from the Sepolia testnet to the Abstract testnet. And you just basically connect your wallet in here, put 0.01 or however many you need, and go ahead and bridge them across to the Abstract testnet like so. So I'll go ahead and click bridge now, and this will ask me to confirm it inside of my wallet. And just to show you the process, I'll go ahead and confirm that and come back in however many minutes it's going to take to actually bridge those funds across. Lucky for me, I've already bridged it across, so I don't need to wait. And we can jump back into our VS Code, make sure this is set to Abstract testnet. And what I might recommend is inside of the deployment script or the interact script, sorry, you might want to just check how much am I sending, maybe lower the amounts so you don't over send your testnet funds away. For me, I'm happy with, let's say 0.001. So we're going to need to load our new Paymaster smart contract. So first we're going to deploy it, then we're going to replace this contract address here. We'll again load it up with some funds, and then we'll shoot off some example transactions. So here you can see I'm just grabbing my private key. Again, please don't use any accounts with real money or that will ever have any real money, just purely test purposes if you are doing this the same way that I am. So I've grabbed that, and then inside of the environment variables file, I will replace the existing value here with my private key, and I'll do that off screen so that you don't see it. So I'll paste that in and save that. So now that is saved, the contract deploy script and interact script is going to be sent from that wallet that I just exported from my extension there. So basically we're ready to jump into the terminal, and we'll clear this out, and we can run npm run. Let's do clean again, because we did actually make a change to our contract in correcting that typo in the error message. So let's clean and compile again. Looks good, successfully compiled. And now we are ready to npm run deploy. So instead of going to our local node running inside of Gawker, this is going to deploy to the Abstract testnet. And you can see it has successfully deployed. And now it's just going to go ahead and actually verify the contract so that we can see the code from the Abstract Block Explorer. So I'll grab this and we can go back to the Abstract Block Explorer, paste that in. So, oh, sorry, I can't see my screen in the background here. So this is explorer.testnet.abs.xyz. Paste the smart contract address in from the terminal. And then you can see it is my Paymaster. It is all the contract tab is available, so you can see the full code. And this is a fresh contract that we've deployed to the testnet here. So now we're ready to swap back into our terminal. Basically, what we're going to do is first, actually, we're not ready to go in the terminal. We need to change the interact script to set line 6, the contract address, to the new smart contract on the Abstract testnet. So go ahead and quickly change that. And then we will run this transaction process again from the terminal. So we'll say npm run interact. And now this time we're pointing to our Abstract testnet smart contract. And you can see the balance check was successful again here. But what I would like to see is actually the response. So let's get rid of these logs of the balance, just comment those out, these ones, and make sure we're logging out the response, and then get rid of the balance before here as well. So now jump back into the terminal, run this again, and this time we'll get a transaction hash and we'll be able to inspect and see, okay, here is the hash, copy and paste that into our Explorer here, paste that transaction hash into the Block Explorer. You can see if we scroll down, it came from my wallet address and we're sending it to one of those rich wallet addresses, and the input data was 69. And here, if we open up the Feed More Details tab, you can see we originally paid 21 cents for the transaction, and you can see we massively overpaid by this than what we needed to. So we got basically all of the gas fees back that we paid for. So we sent in 21 cents. The actual transaction was 0.04 cents. And we therefore got 21 cents back. You can imagine this is kind of rounding up. Basically, the refund would be 21 cents minus 0.04. So it's not quite 21, but it just rounds up to 21 there. So that's why it's a little messy, but that's basically what's happening under the hood, is just rounding up to the nearest 2 decimal number here. Amazing. And the Paymaster that got used was OX57B. And if we swap back to our VS code, we can see number 6 here, OX57B. So it is indeed our Paymaster smart contract actually sponsoring the gas fees for these transactions. So that's it for this video. We have successfully built out our own Paymaster smart contract and showed you how you can quickly run a little script to actually utilize the Paymaster inside of a transaction. Remember, if you got stuck at any point, the source code will be linked in the description, as well as a link to a Discord server where you can speak with myself directly if you get stuck at any point throughout this video. But with that said, if you enjoyed the video, please remember to hit the like button and subscribe to the channel. Helps me out in the algorithm, get this video suggested to you again and other people like you as well. So much appreciated if you do that. With that said, I'll see you in the next one.